My name is Sabrina Ramonov, and in this video, I'm sharing an update on a little simulation I'm building in LangGraph. It's basically collecting coins on an island where this dude is randomly spawned, and there are obstacles like trees and water that the person can't cross, but its objective is to collect coins on the island, and each time it gets a new coin, another coin spawns on the island. And really the objective of the game is to maximize the number of coins it's able to get while minimizing the number of steps it takes. So this is related to AI agent pathfinding. And what you're seeing here is a simulation in action. I'm just letting it run. So here's the map on the left-hand side. This is like a little island that the guy is spawned on. This is the letter B, or Greek alphabet beta, for the little agents. Just named it after my other puppy, Bubble, who's not in the background. That one is Hugs right now, playing with her toys very loudly. And then C is the coin. So Bubble here is trying to get over to the coin over here in as few steps as possible without getting stuck in trees and stuff. And so here's the last thought that they have. And so just roughly how it works, let me go to the code base. Hopefully you can see this. This is basically what the agent's internal graph state looks like. And I'll show you the LangSmith dashboard as well. So basically you start here and act, and then acting consists of two steps. First, thinking about what you're going to do, so generating a thought, and then selecting an action. Now for this simple version, there are really only two possible actions, move or collect, but you can imagine in a more complex game, there might be other actions that this agent could take. So anyway, so it starts at act, and then it thinks, and then decides either to move or collect a coin if it's in the same location as the coin. And then after moving or collecting, then the agent goes back to act. And then here you can see in the comments, this is what we have access to when writing the prompt. The decider prompt, for example, is the prompt that generates the thoughts, and it has access to the agent's current position, the position of the coin, the last feedback it received from the environment. For example, if it hits a tree, then it gets feedback that, hey, you tried to move left, but a tree is in the way. So actually it just showed up here, right here. Tried moving right last time, but there was a tree in the way. And one of the challenges with LLM-powered agent pathfinding is avoiding obstacles. So the last parameter here is memory, but so far I've only implemented one-step memory. The problem with that is like the agent will move, left, and then there's a tree. Okay, it remembers there's a tree on the left, but suppose there's another tree on the right, and then it tries to move right. Okay, the feedback from the environment is now there's a tree from the right, but because it's one-step memory, it already forgot about the tree on the left. And so I'll often run into situations on more difficult maps where the agent is like trying to move left, trying to move right, but there's a tree on either side, so it gets stuck. All right, now I'm going to exit the simulation and walk through the code base a little bit so you can see what things you can change. So as I mentioned before, this is the agent's internal graph state, and we'll take a look at LangSmith in a bit so you can see what that looks like in practice. And then here are various prompts. So this is the backstory of the agent, and it's prepended to every call to ChatGPT as a system message. So here's the agent's backstory. He is a collector of rare coins stranded on a deserted island. The coins spawn randomly on the island. Every time he picks up a coin, a new coin spawns somewhere else, and locations are represented as row column coordinates. And ultimately, the agent's goal is to collect as many coins as possible. Now, the next prompt is called the decider prompt, and that's basically what generates the thought that guides the agent's decision. So before, I didn't have that step of thinking before acting, and the performance was even worse in terms of like pathfinding and getting to the coin's location efficiently. So I decided to introduce this thinking step preceding each action decision so that we would get higher accuracy in terms of what the agent should be doing. So the decider prompt basically says, this is your current location. Here's the coin's location. To make a decision, first generate a thought that will govern your future action. And that thought should be based on your goal, which is collecting coins, based on your position on the island, and explain what influenced your thought. And then a little chain of thought, take a deep breath, and generate your thought step by step. So this prompt already is working pretty well on islands that don't have a lot of obstacles. Here you can see down here, I'm actually playing around with the decider prompt. So this is fun as well. So this version of the decider prompt is actually generated by Anthropic's prompt generator. So I kind of gave Anthropic, the goal of the prompt and the input and the expected output, and then Anthropic generated this kind of cleaned up version of the prompt. It hasn't worked like significantly better, but I thought it was a fun experiment playing around with Anthropic's prompt generator. Then you can see here the model for testing purposes, just using 3.5 turbo because it's cheaper, temperature, and then the thought action prompt is what converts the agent's thoughts into an action. And remember, there are only two possible actions: move towards the coin or collect the coin if you are in the same row column coordinate as the coin. And then here are some other parameters as well. So for testing the initial prompt, I had an island with no trees, which made it much easier. So that's just a barren island, which I'll show you here. So let's do generate barren, okay. And then here are some additional map generation parameters. So if you do choose an island with a bunch of trees and stuff, you can set the tree density. So like how many trees are there? And then this is, radius of the island, how big should it be and stuff. And then step through mode is what, I'll set this to true. This is what enables us to step through each time step of the simulation. So just to recap, I just switched step through mode to true, so we'll be able to step through things. And then I switched the map generation to a barren island with no trees. So let's see what that looks like. Okay, so you can see here the map now. It's pretty plain, just no obstacles, no trees, no water or anything. And then I just press S to step through the simulation. So now the agent is thinking, and this is its last thoughts. In the middle column here, I'm determined to collect as many coins as possible, blah, blah, blah. The current location is pretty far, so I should consider exploring nearby areas first in case it finds more coins. Yeah, that's right. We didn't specify that there's only one coin at any given time. So here, just stepping through it. So it actually moved up away from the coin location because it's trying to find other coins. Okay, thinking. Yeah, it really wants to explore nearby areas, so isn't that interesting? Because we didn't specify that there's no other coins on the island. And just to take a step back, why I'm building this is because eventually I want to build multi-agent simulations with objectives like games and stuff. So like a canonical example might be a single-player survival game. Like literally you're stranded on an island and you have to make sure you drink enough water, eat enough food, and have shelter to survive. And this is the basis of that. It looks pretty basic now, but check back in a year, maybe 2 or 3 years, and hopefully I'll get to my survival island game. Heavily inspired by games that I've recently played, like Valheim, for example, is a really fun multiplayer survival open world. This agent's not doing really well heading to the coin, so we might want to switch up the prompt real quick so it actually heads towards the coin that it knows exists. So what I'm going to do now is basically comment out this prompt, and then we'll uncomment this decider prompt. And this is the one that I used, what is it called? Anthropic's prompt generator. The only thing that kind of made more explicit, so the difference between this one and the previous one, is to take into account feedback from the environment. So when it runs into trees, for example, or other obstacles, make sure it incorporates that feedback and its next thought that governs its next action. And here, I say your primary goal is collecting the coin. So hopefully that will be sufficient to get the agent to actually move towards the coin instead of bumbling around. Although in survival games, I like to bumble around and explore a lot of nearby areas. So that's okay. What is it, Hugs? What is it? You okay? Okay. Oh, now he's thinking, I should prioritize moving towards the coin as it is my primary goal. And just remember here that in this prompt, I did specify that that is the primary goal, just to reduce the exploration and bouncing around everywhere when the agent is far from the coin. So now he's moving towards the coin. Hugs, what is it? What is it, Hugs? And then, okay, he's moving. Is he gonna get there? Oops. Okay, I pressed something other than S. And you might have noticed like the last feedback box is empty here because there is no information the agent is getting from the environment because we have no obstacles. So this is, again, a barren map. There's no trees, no water. So there's no like environment feedback of like, oh, you shouldn't go here because there's a tree. And that's why that last column over there is blank. Okay, and then it keeps moving. Okay. All right, so the next move should be moving at the same location as the coin, and then the next action after that should be collecting the coin if our agent is working properly. Yeah, so he's thinking, okay, so he's now moved to the same spot as a coin, but the next action needs to be collecting the coin. So let's see if he does that. Okay. Okay, awesome. So he just collected the coin. You can see here the last thought. I'm currently at this position. The coin is also at my position. The last feedback I received is missing, so I should prioritize collecting the coin. My primary goal, blah, 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 is to collect coin, so I should pick it up without delay. And then the feedback from the environment is, hey, you collected a coin, a new coin has spawned somewhere on the island. And then it will use that feedback to incorporate in its next thought generation, which will be, oh, hey, I should move towards the new coin that generated. So that was, again, a barren map. But now let's go back and do a map island. I think this one, honestly, is prettier. Anyway, and so the parameters we're going to be, the main parameter we're going to be adjusting is the difficulty. So the closer this parameter is to 0, the easier the map is, the fewer trees there are. And then if you do a high value, there will be like lots of trees. So let's just try 0.8 and see what the map is that is generated. Okay, yeah, so there's literally no path to the coin because the agent can only move up, down, left, right. And yeah, I don't have my reading glasses on, but it looks like the agent is just kind of trapped between two squares. But that's kind of the hard part about if you set the difficulty to really high, sometimes there's literally no path. But let me at least point out kind of the feedback. So here, in the last feedback column on the right-hand side, it says you tried moving right last time, but there was a tree in the way. So now the next action is most likely going to be not moving right. So here you can see it tried to move down. You tried moving down, but there was a tree in the way. Oh, poor agent. And then you tried moving up last time, but there was a tree in the way. Is it ever going to move left? Yeah, it's just bouncing around the directions where there are trees. Okay, it eventually moved left. Probabilistic. So, but yeah, there's just no path to the tree, unfortunately. So I'm gonna try with another map. So let's do a few trees, not too hard. Yeah, there's no path to that coin either. So I'm just gonna press Q and generate another map. We just want at least, okay, I mean, that's not super great, but I'll take it. All right, so let me just step through the simulation. So he's currently at this position, blah, blah, blah. Collect the coin. Okay. Yeah, I mean, the tree isn't really presenting itself as an obstacle in this scenario, but still here, it's still cool to see my agent move around on a little island. Okay, let's try another map, hopefully that actually has legit trees as obstacles. Again, there's no path to that coin. So, that's not bad. Let's see. Yeah, because it kind of has to go left. Okay, let's see if it oh no, it's gonna run into an obstacle. Yeah, because it doesn't know the tree's there, right? So like it's just moving along, exploring. So if it tries to move left again, okay, perfect. So feedback is there was a tree in the way. So which way is it gonna go? Up, down, right. So here you can see the last thought. Based on the last feedback, I should avoid moving left due to the tree obstruction. So it recognizes the tree, incorporates the feedback. Fortunately, it moves up, so it's trying to go around through going up and left, but it doesn't realize there's another tree there. Okay, so now it moves down, but I'm afraid it might try to move left again. Tree, yeah, so it tried to move left again, but there's a tree. So it really needs to move down. Okay, which way is it gonna move? Okay, it knows it should move left. Okay, now it finally moved down, and then hopefully it'll move left to get towards the coin and not, oh no. Yeah, this is actually one of my struggles right now since there's only like one step memory, which is not super useful. In my initial prototypes, it does tend to work a lot better if there's like a couple steps in the memory queue and not just one, because now you're going to see it kind of bounce back and forth, up, down, up, down. Yeah, see, up, like by the time so what's happening is by the time it moves down, it's already forgotten that there was a tree if it moves up and left again. That's why it keeps moving down and up and down and up. Okay, so I'm going to quit this. So that's one of the challenges that I'm actually currently facing and working on. Do I want to implement like a real memory, so more than just remembering one step? Or do I want to just use, tools for pathfinding, like just calling a known machine learning algorithm for pathfinding, especially if the agent knows the coin's location. So those are the couple options I am debating between. So the next thing I want to show is what's actually happening in LangGraph. So you can see here is the system prompt, and then this is the human prompt. So like we mentioned in the beginning, the system prompt is the agent's backstory, that they're collecting rare coins, deserted on a desert island where coins randomly spawn, etc. And then here is the new prompt that we tried, saying, you're on a 2D grid, blah, blah, blah. Primary goal is collecting the coin, and heavily incorporate the last feedback you received. And again, feedback refers to feedback from the environment, such as there's a coin, or a coin just spawned, or you ran into a tree. And then here's the output, which is the thought that governs the action. And there are only two possible actions, moving or collecting a coin in the same position as the agent. Oh, hi, Hugs. And here's where I initialize the state graph. So like I mentioned, kind of in the previous ASCII diagram, we start in the act node, and then there's two other nodes, move or collect. And then the edges are bidirectional. So act move have a bidirectional edge, and then act collect have a bidirectional edge. And yeah, this is pretty much like the state of the entire game. So you have the map itself, the current position of the agent, the score, which is how many coins they've collected, how many steps they've taken, the current action, the last thought they had that governed the future action, and also the last feedback the agent received from the environment, such as there's a tree in the way the last time you move a certain direction. Again, I actually really enjoy just running the simulation and seeing it bop up and down. I'm going to remove step through mode. Let's keep the difficulty 0.2 because that seems hard enough for our little guy. So, oh, this is a nice island map. Yeah, it's a pretty big island. Okay, I mean, that one was pretty easy, but let's see where the next coin spawns. Oh my gosh, the coin spawned next to him. All right, he's getting really lucky on this map. Okay, now it's all the way there. And still no trees in the way, but I feel like the next coin generation will be interesting, hopefully. Okay, so here it's getting the coin. And again, I'm just running the simulation. I'm not stepping through. So it's just kind of fun to watch the little agent move around. Okay, so now it has to go all the way over there. So let's see how it handles pathfinding there. So yeah, see, it already ran into, so it's now going back and forth. Yeah, you tried moving down, but there's a tree. Is it going to try moving up? No, finally it goes left. Okay. I feel like I'm a commentator for like a game or something. like I don't know what the player is actually gonna do. It's probabilistic, and this is pathfinding powered by LLMs. We're not using like well-known machine learning algorithms to efficiently navigate from point A to point B. Oh man, it's just bouncing back and forth. Oh no. It's kind of weird though. Like, why is it bouncing back and forth there when there's no feedback that it's running into a tree? So why is it going up and down at all? Okay, stop doing that, thank goodness. Okay. Oh, it's going up. Why is it going so far away from the coin? I need to plan a route that would... Oh man, that's so interesting. Its last thought is like, the last feedback received, although unspecified, should be taken into account to ensure a safe path to the coin. So I think it might be heavily weighting the last, like it didn't even get any feedback, but it's trying to find a safe path. So let me exit this real quick. Let me change that prompt a little bit. Yeah, because it's highly weighting the last feedback. I'm just going to remove this. Feedback you received. Yeah, if you receive no feedback, ignore this point. Okay. Thank you, GitHub Copilot. It just auto-completed that, yeah. So here I'm trying to just deprioritize a little bit the weight on the last feedback because it's getting tripped up by the last feedback even though there was no feedback. I'm just going to regenerate the map because I don't like that one. Yeah, I kind of want a big island that we had before. All right, he's moving towards the coin. Agents is, oh no, he keeps going up and down. He's going further away from the coin. He's really going far away from the coin. Yeah, see, the last feedback I received is missing, so it's complaining about that. Hang on. Let's say that is specified. Let's put it over here, see if that works better. Unspecified. Yeah, ignore it. Okay. Ooh, that's a nice map. All right. Okay. All right, moved left, but there's a tree, or at least it's heading towards the coin this time and not away from the coin. Okay. So, all right, sweet. Much better, heading towards the coin. So, yeah, before it was in a kind of weird, not loop, but just like a weird thought process because it kept trying to incorporate the last feedback, but the last feedback was unspecified if the agent did not run into a tree. And so I don't know what it was literally moving far away from the coin. So just change that up real quick. So here, so the thought is influenced by the last feedback. If unspecified, ignore it. This will be interesting because yeah, it's kind of stuck right now with the trees. Like to actually get to the coin, it has to move all the way to the right. And again, we only have one step memory. By the time the agent moves up one square, it's already forgotten that there's a bunch of trees below it. And so we're kind of hoping, like probabilistically, that the agent will move up and then probabilistically move right, even though the coin is to the south. And that's what makes it difficult. So like the agent moves up, okay, it's forgotten there's a bunch of trees to the south, and it knows the coin is to the south, so it wants to move to the south. And that's why it kind of keeps getting stuck like that. And then it tries to move right as well because technically the coin is south and right, but there's a tree in the way. So yeah, I just wanted to share my progress building my little agent simulation framework. It is really interesting, like running into all sorts of challenges because I am trying to use LLMs for as much as possible. They may not be the best fit for things like pathfinding, where if you know where you want to go and you have a set of obstacles in the way, there are well-known machine learning algorithms that perform efficiently for that pathfinding scenario. But kind of my goal is to learn as much as possible building this agent simulation framework from scratch. And my eventual goal is to build kind of like mini survival game with agents, trying to survive by drinking water, eating food, having shelter, that kind of thing. All right, my name's Sabrina Ramonov. If you enjoyed this video, hit like, hit subscribe, drop a comment below. Look forward to hearing from you.